first session. We introduced the series last week on Tuesday. Now for today, it's our second session, and for this second session, we'll be covering microcontrollers, like from the we'll be looking at microcontrollers from the complete basics, like for someone who does not know what a microcontroller is, and we'll build up from there. Because okay, this session is for IoT, so I saw it wise that we look at microcontrollers, because it will not make sense if I'm teaching you something but you don't know even the thing that you're using. So yeah, for myself, I'm Collins Nyegoti. I'm the host for this session. Okay, I'm the host for the series, and what I do, I'm a IoT and embedded systems developer. For those who are in the previous session, I believe you know what IoT and embedded systems is. For those who are not there, okay, IoT basically is connecting devices. IoT in full is Internet of Things, and it's the sorry for that. I was admitting someone to the call. Is the technology that enables us to connect devices to the internet so that they can share data. As right now, you know, a lot of things are the word smart. Smart means it's able to connect to the internet. There are smart fridges, smartphones, even your phone is an IoT device. Yeah, so that's what I do. Embedded systems is the normal electronics, but if it is connected to the internet, it becomes an IoT device. But just a normal like mouse, that's an embedded system device. Normal electronics too. Uh, Secondly, I'm a beta MLSA. MLSA is Microsoft Learn Student Ambassador. That is the like community I'm holding this series under. So it's a community of people who are passionate about technology, people who are interested in building, learning, networking. So basically, that's what MLSA is. And if you're interested in becoming an MLSA, let me share the link. And also you can also DM me. You can find me in your tent, and I'll help you to become a Microsoft ambassador. There are cool benefits to it. It's pretty interesting. Also, I'm the MLSA lead for Dekut. Meaning I'm a student at Dedan Kimathi, of course. Yeah, and also I'm the co-founder of Go Technologies. Go Technologies is a startup that we build electronic devices. Okay, I think it's okay being an embedded system guy. So we do build them. Uh, we do have in-house products, the clocking device, a biometric clocking device. We have a solar charge converter, but I don't want to go to the details of the devices, but that's what we do. We do hardware manufacturing, we do hardware IoT development, software development. So anything tech, we are your guys. Collins, I know you know Kevin. Kevin, you're together in Go Technologies. He's my co-founder there, and I'm also a fifth year mechatronics engineering student at Dedan Kimathi. How many here are from Dedan Kimathi? Just to know the demographic of my audience. Can you react if you are from Dekut? I've seen one. Oh, only one person. Okay. Okay. Uh, I saw it wise to do like an introduction of the IoT 101 series again for those who are not there. So this series is a community series, community in bold, where we are covering everything IoT and embedded systems. But what I mean by when I say community series, it's not me coming to teach you things. It's not like the teacher-student, lecturer-student type of series. It's more peer-to-peer. By peer-to-peer means like everyone has a chance to learn, share, and network. And the scope will be IoT beginner series, a session like this, teaching about microcontrollers. I will be having mini projects. We'll be working on things together. Cool stuff. C++ sessions, because embedded systems is mostly done in C++. Okay, also C, but I'm not good at C, so I'll cover what I know. Unless someone who is proficient in C we can also have C sessions. show and tell sessions. If there's something you have worked on that you think it's really cool and you would like to show out, so we'll be having show and tell sessions. We'll having updates on IoT trends and developments. If things come out, there are new releases, such kinds of things, we'll be covering them here. And we'll also be having guest speakers. I'll be trying to find people in the industry to come and share to us about how things are. So we'll be having, it will not only be me every other week here talking. Yeah, so with different voices. Yeah, so as I said, it's a community series. So community from the word. Yeah. Okay. So let's get to the matter that has brought us here today, being microcontrollers. Uh-huh. So what is a microcontroller? I'd asked this question prior to us starting, and Collins gave a very precise answer. So a microcontroller is a uh, sorry about that. That's a notification to do something. A second. Okay. Sorry about that. So a microcontroller or MCU is a small self-contained computer on a chip. Basically, the normal computer but it's smaller and on a small chip, rather than the big PCs or laptops that you are used to. So it includes the CPU, like a normal computer, the CPU, the memory, input and output pins. Okay, the normal CPU, the normal PC, you can plug in your keyboard, the monitor, etc. It's kind of similar, but on a smaller scale, and it has the pins, and this allows it to control electronic devices and interact with sensors, motors, and other components. So basically, that's a microcontroller. You can call it a microcomputer, or MCUs, not Marvel Cinematic Universe. These is the microcontrollers, and the features of it is the compactness. You can see the picture there. It's pretty small, so it enables you to work on tiny things, because you can imagine something like a mouse. Mouse cannot work with that big. Okay, you can put the CPU, the Intels, but that will be like putting a turbo engine on a bicycle. It doesn't make sense. They are programmable. That means they can be coded for different tasks. Uh, it's all in one combined. It combines the CPU, the RAM, and storage. There's a microcontroller and microprocessor, and this the all-in-one is the thing that differentiates between a microcontroller and a microprocessor. We'll be looking at microprocessors next. It has low power consumption, because basically embedded systems usually work in situations where you need to conserve power, so they have lower power consumption compared to the other computers. Yeah, microprocessor. What's a microprocessor? Basically, this is the brain of a computer. Okay, the brain is the CPU, but yeah, it's the brain of a computer. It's a single chip that performs calculations and runs instructions to operate a system. Basically, the way a microcontroller is, it has the memory, the CPU, and etc. So the microprocessor is only the CPU individually. It doesn't have the other components. Yeah, so to work with it, you have to like connect the other components externally. You have to have a chip for the memory. You have to for the input and output pins. Everything is external, different from the microcontroller, where everything comes together. And the key features of a microprocessor is, one, high performance. It's able to handle like complex tasks. As you know, any laptop you have, it has a microprocessor inside, be it the Intel, be it the AMD, the Kina Ryzen. Yeah, so, and they're able to handle complex tasks. External dependencies. Uh, as I've said, this one comes as a single chip. It doesn't have the peripheral, so everything needs to be separate RAM, storage, and everything peripheral. It's used in PCs and servers. Yeah, for those who have logged in with their lab, even phones have microprocessors. Basically, it's the CPU, the brain of any electronic device. So I have here a graphic that shows shows how like it works. As you can see, let me get a pointer. As you can see, as a whole, it forms the microcontroller. The microcontroller has the timer. A timer is a part of the microcontroller that controls. It keeps track of time from the name itself. The input devices, RAM, ROM, these are memory, serial interface. They are all in one chip. But you find the microprocessor. It's single single as the CPU, and everything else is connected to it peripherally or externally. So basically, that's the difference between a microcontroller and a microprocessor. Yeah, I hope you have understood, because this is something that even in the engineering field, I do mechatronics, and in my class a lot of people do confuse that. So it would be nice to know the difference, so that you cannot like make a fool out of yourself out there talking about microprocessor, and what you're talking about is a microcontroller. Yeah, so the difference between the microprocessor and microcontroller, uh, first of all, is the microcontroller being it that it's everything is integrated together. It has highly integrated components, the CPU, memory, etc. As I've mentioned, the timers. Yeah, but for the microprocessors, external components are required. Uh, Another thing is the processing power. As I previously mentioned, the microcontroller is used to work on like smaller tasks, so processing power is kind of moderate. But for the microprocessor, you find that its processing power is really high, really high. Power consumption, microcontrollers are low power consumption. Okay, these things, from what I previously mentioned, you can like kind of like know why the low power consumption, and the microprocessor is higher power consumption, because something like the speed, microprocessors work at gigahertz, and microcontrollers work at megahertz. So it's yeah, it's bound to use more power. Costs, microcontrollers being like less complex, they have low cost and complexities, and they're ideal for consistent projects and designs. But for microprocessors, they're really expensive. If you go like research, if you follow Nvidia, you can see the price that they're using. They're selling their GPUs. Yeah, so you can imagine the costs. They're really expensive. Security, for MCUs, the security is already integrated in the hardware modules, and it's lightweight, because basically the things that it does are like, okay, I'll not call them basic, but they're not that complex. They don't do complex computation. But for microprocessors, I'm using MCU and MPU for ease, because those words are long. They are more advanced, scalable, and ideal for high performance, high security environments. Real-time processing, or RTOS. MCUs are excellent for real-time tasks, often used using a bare metal or okay. By bare metal, it means that the code runs directly on the CPU of the microcontroller. There's no operating system where the code, like your laptop, it has, maybe I'm using Ubuntu, so that's my OS. But for when I mean bare metal, it means the code that runs directly on the controller itself. Like the controller is manipulating registers, etc. uh, Lightweight RTOS, real-time operating system. These are okay. These are system that is the OS that is used for embedded system. It's kind of lightweight compared to the normal Linux, Windows, Macs. But there's also the embedded Linux. But these are things that we'll cover in future. But the MPUs, they support fully fledged operating systems with real-time processing. The embedded Linux, though MCUs also can also like hold embedded Linux, but these work with, perfect example being your computer having the Windows or the Linux that you are using. Okay, okay. So far, any question? Any question so far? I guess there are no questions. Okay, Collins, your hand has been up, so I don't know if you've forgotten it or you have something.
I had forgotten it.
Oh, okay. Key components of a microcontroller. So let me get the pointer back, the laser. So I'll just look at the microcontroller itself and then the microcontroller. Or the microprocessor, then the microcontroller. So the microprocessor being the single chip, it only has the CPU, the ALU being the arithmetic logic unit, and registers. Though this diagram is not correct because the ALUs and registers are usually inside the CPU. Like the CPU has three parts: the logic unit and registers and the control unit. But okay, for the sake of the graphic, we'll just have them separate. Yeah. Okay, the ALU is the part that handles the calculations, the logic, the if-else, and etc. So don't like be surprised what that is. Registers are mainly memory units to handle like data that is supposed to be worked on like immediately, or addresses to memory locations. So that's what registers are. So those are the parts of microcontroller. Okay, and the control bus, the data bus. These are I can say like connections to transfer data. This is the control bus. It has the commands, data bus to send the data, address. Okay, the address comes from the registers. Yeah. Okay, with time you'll get to like understand these things, and the components of a microcontroller, these are similar. Okay, it's the same, but the other things, the counters, the timers, the RAMs, counters that they keep track of. Uh, okay, they count depending on what you're doing, but from the name, they count timers. They keep track of time, like they count clock cycles at a very fast pace, depending on the bits of your microcontroller. RAM, ROM, if you handle like, these are basically normal memories, random access, read only, yeah. Input, input, output ports. This is to send data in and out and of the, the, the MCU. Yeah, so these are key components, the CPU, the memory. So memory stores the program code and temporal data, and they're the input and output pins. So if you, okay, with time you'll get to see these things. Right now, I'm mentioning them majorly theoretically, but with time you'll get, these are things that you'll be working with like on a daily, okay, regularly. Timers is used to precise timing of and event counting. There are situations that you need to keep track of time or events. Analog to digital converters, convert analog to signals to digital and vice versa. Because, okay, for example, when working with sensors, there are some sensors that produce analog data. So that analog uh, that analog signals must be converted to digital for the, because most microprocessors work with data digitally, and there's also the vice versa, analog digital to analog. Yeah, the communication interfaces. This is something that we'll cover in a different session because it's kind of wide. So there's the UART, SPIs, etc. This falls under the, what is it? Okay, the serial, okay, it's not in this graphic, but it falls under there. So basically, when you get a microcontroller, like these are the things that are expected to be there. Any microcontroller you find, basically these are the things that are on any microcontroller. I know I'm repeating myself, but yeah. Microcontroller classifications. Okay, basically, MCUs are classified based on their bits, the number of bits they can take, like they manipulate at a time, the memory architecture, okay, the devices and instruction set. Uh, Funny thing, okay, I've remembered something. Okay, preparing for this session, I found myself like in my course notes and PTSD. These things. So okay, so for the bits, the number of bits describe the data path in which defines the MCU bit definition. Okay, I don't know what I was saying there. Okay, basically, what I mean is an MCU is categorized by the number of bits it can describe a data path with like a number of bits it can send or manipulate at a time. So generally, the more the bit definition, the more powerful or fast the MCU is, meaning it can manipulate a lot of data at once. And in bits in microcontrollers, there are 8-bit, 16-bit, 32 bits. For microprocessors, they go to 64 bits, but microcontrollers mainly work with these three types. And for the 8-bits MCU, it means the data bus is 8 bits wide, 0 to 7. Can send data, the addresses are 8 bits wide. And being having only 8 bits, you find that its clock speed is not that high, 1 to 50 megahertz, and that's pretty slow compared to normal computers which work with gigahertz, somewhere from 2 to around 4, almost 4. Yeah, so you can that's pretty low. Memory, it has limited addressing. Okay, because the bit width is not that large. So yeah, basically they work with 64 kilobytes, but in normal programs that will be more than enough. But compared to normal computers, that's pretty small. And applications for that are things that are simple. Uh, Sorry for that. Uh, like simple control system, toys, thermostats, basic sensors. You find things that don't need a lot of computation. And the 16-bit, it's just similar to the 8-bit. Difference is it has a 16. The data bus is 16 bits wide, and that makes the clock speed be a bit higher compared to the other one that is 8 to 100. Though it's still low, but it's enough for normal uh, your normal projects, etc. Because IoT, okay, basically embedded, they don't need a lot of processing, a lot of speed. The memory is up to 1 MB, which is better for large programs, and it's used in medical devices, the glucose meter, hearing aids. Yeah, in automotive system, the dashboard controls, EMUs. Yeah, and also in industries, industrial sensors with moderate processing needs. And that two bit, okay, same, but that 2 bits wide, which enables it to handle complex data effectively, because processing that 2 bits of data, it makes the computer faster. By how fast? 50 to 100 megahertz. That's a good improvement. And memory, it's supposed up to GBs of address space. Yeah, and external memory if possible. Some handle external memory, others can't. And applications being the IoT devices, smart home gadgets like the smart fridges, yeah, smart lighting. Okay, though lighting does not need that much, but yeah, the robotics and motor control, and also advanced embedded systems, touchscreen drones that need a good amount of computation, though not that much compared that, yeah. Kizungu imekata. Okay, they need a lot of computation, but not as much as in normal computers, if you get what I mean. So next we'll be looking at the popular microcontroller families. Basically, these are groups of microcontrollers that you can be working with. The first one is the ARM Cortex-based MCUs. These are really popular. If you're into embedded systems, you'll find yourself working with an STM. So they're produced by STM Microelectronics. These are a Swiss company. There's also Texas Instrumentals, Microchip. There are a number of producers for ARM MCUs, and The popular ones are the STM32. This is the chip, the STM32 chip, but here you can see it embedded in like the whole system. This is the chip singly, and this is the like MCU, STM32 MCU. Yeah, so there's the STM32 from STM Electronics, STM32F. There are a number of them, but there's the Kinetics, LPC, some are 5. Yeah, okay. Different projects require different MCUs, so it's up to you, depending on what you're working on, to know what type of if you're working with Cortex, which one you'll be using. So there's a whole process to like deciding on a good MCU to use, which will look a bit later. And the feature being high performance, low power. Okay, basically MCUs use low power, extensive peripherals. As you can see from me, it has a number of things there, and has a strong ecosystem because STMs are pretty common. So you find that there are a lot of people using it. So you find a lot of libraries, ecosystems, documentation on things you're working with. So it has a really strong ecosystem, and they're also pretty good too. Quality wise, they're pretty good. The other one is the AVR. AVR. This is produced by Microchip, formerly Atmel. These are the ones that are on, like the Atmega. Atmega, they're the ones that are on the Arduino. There's a whole Atmega series. There's that two 8P. There's that two like that. There's a whole series. Each has its own speed, memory, etc. There's the at tiny if you need like ultra small and ultra small MCU that uses low power. There's the at tiny. There's the IVR ADB. This is like kind of modern with better peripherals. Yeah, the AVRs are also common, but okay, mostly they're on. You can find them on other microcontrollers. So the features being easy to use. Okay, I was admitting someone. Being easy to use, great for beginners, and widely supported. Yeah, they're widely supported. The common ones for IoT, which we'll be using regularly, is the ESPs. Okay, they're popular because they have Wi-Fi and Bluetooth capabilities. For the others, the STMs and the AVRs, you find that majority of them don't have Wi-Fi capabilities or Bluetooth. So they can only be used as embedded systems in embedded system projects, but not IoT projects. But ESP solves that because it has the both, and produced by Expressive Systems, a Chinese company. Popular series, the first one was ESP-2A66. This had only Wi-Fi, didn't have Bluetooth. Then came the ESP-2, combined Bluetooth with the Wi-Fi. Then came like sub modules of ESP-2. There's the S2, S3, C3, C6. Though there's a company called Shao that we look into that produce them, but they're really popular. You can see they're pretty small and very good quality wise. Quality wise, the peak, though I've not gotten the chance to work with the peak, produced by Microchip. This is the peak series, peak 10, 12, 13, 16, peak 24, which is 16-bit. DS Peak 32. Okay, I've not worked with the Peak family, but I hear they are good, durable, industrial grade. Okay, basically these are mainly used for like industrial systems. So yeah, good for legacy systems. Legacy systems, how can I put it? Like this kind of factory server environment, that kind of environment. That's where they are used. Personally, I've not like, okay, I've seen them, but I've not like worked with them. But the good stuff, good stuff. Hmm. And other popular MCUs, the Arduino development boards. If you're okay, majority of you, I believe I've seen the Arduinos because they are pretty popular. Like they are the hello world of embedded systems. Because if you're getting into it, like the the first MCU you'll work with is most probably the Arduino, produced by the Arduino LLC, and the series being the Arduino Uno, there's the Nano, Mega, there are a number of them, Nano, yeah, there's the Giga, there's the Micro, there's the Pro Mini. There are a lot of Arduinos. These are good. They are beginner friendly because it has a beginner friendly IDE. It's easy to use. Vast community. A lot of people are using it. Though Arduino, it has its limitations. When I like interact with an Arduino, I just remember like some few guys a few years back in my course who like produced a project that was working with an Arduino, and they were told like that's a toy because okay, basically Arduino are development boards, something to like to prototype with, but when you're building something to go into the industry, your Arduino can't be your go-to microcontroller. Though surprisingly, Ukraine they were using Arduinos on their drones during the ongoing Ukraine-Russia war. I saw like an article about some drones working with Arduino, which was pretty interesting. Yeah. So they have standardized pinouts, shield for easy expansion, compatibility, compatible with multiple third-party clones and variants. Okay, Arduino is open source, so you'll find like when you order an Arduino, the chances that you'll find an Arduino from Arduino LLC are like small because it's open source. So different companies have created like clones of it, but they still work the same. And yeah, another one is the Seed Studio or the Shows. These are pretty good. Uh, okay, though they all look the same. Yeah, the Shao S some D12, D21, RP2040. But they you should follow the Seed Studio Twitter page. They usually have giveaways for the microcontrollers and other components. Last year I won the ESP32C3. I own it in their page. So you should follow their page. Features, their thumb size, they're pretty small. You can see it's 20 millimeters by 17.5 by 20. It's pretty small, good for like space constricted projects. Low power, designed and portable. They can be used like also as SMD. I wish I had included a photo from the back. Okay, SMD I mean like surface mount device. You don't have to like to connect them to like via the pins from here. They have like the SMD patch at the back, so like and like you can just like place them on top of projects, making them good for portable and wearable projects. uh they have built-in like wireless communication, the BLEs, Bluetooth and Wi-Fi. Okay, in select models, not all of them, some of them do, others don't. Support Arduino, Circuit Python. Yeah, they support a lot. Okay, basically a number of SHAO like microcontrollers are from like the ESPs, like the ESP-2, C3, there's the C6, S3, S6, like they are kind of built from like the ESP. It's also a Chinese company, so it's 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 expected because those guys collaborate a lot, kind of. Yeah, so factors to consider when choosing a microcontroller, because there are a lot of them. There are over, if you are in our session last week, you can see there are like over 1,500 microprocessors out there, frameworks about over 40. So when deciding on what to work with, so what are the factors to consider? And the first one, someone else is in control. Who is taking control of the slides from me? The first thing to consider is performance. So you look at the speed, depending on what you're working with. If what you're working with does complex tasks, you need something that is faster. But if not, just an 8-bit MCU can work. Memory, if the, okay, if if it's working on something bigger, so it need a bigger space to work with the code base and the data, etc. Power, if your project is battery powered, then you need something that is using low power, like the MSP for 30 or the STM32L. But also sleep modes. If you are if you need to conserve power, look for MCUs that have like the sleep modes so that they can go to sleep when inactive. So this is critical for energy efficiency. So when you are choosing an MCU, you should look at the power. Another thing is connectivity. Is your project, does it need any kind of connectivity, be it Wi-Fi, Bluetooth? So if it does, then the ESPs and the SHAOs are your go-to because they have the Bluetooth connectivity. But if you don't need the connectivity, you can work with any MCU as long as it has the performance and the power that you need. If you need wired connectivity like USB, Ethernet, there are MCUs that have that, the STM32, PIC32, they do that. Another thing that you look is the number of peripherals that you're connecting and IO pins. If you're working on a project that has a lot of pins, a lot of other peripherals, it will be using a number of pins, a lot of pins. So you look at the number of GPU pins your MCU can handle, so that you don't find yourself working on a project that's working with an MCU that has less pins that what you require. Having more is good, but less, that can't work. Uh, ADC, if it has the analog to digital converters and pulse width modulation, because if you're connecting the MCUs to like analog sensors, etc., these signals have to be converted to digital for them to work. Another is pulse width modulation. Pulse width modulation is, I'd say, the ability for MCUs to like vary the pulse width of signals, analog signals, but keep the frequency the same, of which it comes pretty handy in some cases. Easy to use. Uh, if you're a beginner, Arduino is your go-to, or ESP. If you're advanced, STMs, etc. The RP420. Okay, there are a number of advanced, the peaks. Yeah, so those are for the advanced. And for them, you'll be using the C++. But for the Arduino, they have the Arduino framework, which makes it easier to work to program the microcontroller. ESPs, they can also work with the Arduino framework, but they have the ESP IDF, IoT development. What does the F stand for? Framework. Yeah, so the IDF, which are good for beginners, but for advanced, yeah, C++, you need to like write code. Another thing to look at, costs. If you gonna do you have that moolah and the size. So if you don't have the money, just go for a cheaper MCU. But if you have the money, you can go for the expensive one, the rasps, raspberry. Oh, but they didn't cover rasp. But those are things that we look into in future. Industrial, the STM32, the peaks, the ecosystem, 4.7 ecosystem, like that's the how many people in the industry are using it. So libraries and communities go for that. Arduino and ESP32, they have the also STM. It has a good community behind it. Yeah, so it's usually good to work with something that has a lot of people are working with, so that if you are lost or can't do something, at least you can find someone to help you. Debugging, yeah, okay, different microcontrollers use different debugging methods. There's the SWD, which is single wire debugging, JTAG, joint test. Okay, I don't remember the other parts, but yeah, these are basically mainly for STMs. There's also the UART. Okay, but normal Arduinos, a normal like serial monitor can do that. But yeah. Feature proofing, is it upgradable? Is it available in stock? STM family scales well. That means, okay, you can find controllers that are increasing in like their abilities like very well. So it's not like what can I use for example? I have 5 minutes left. Okay, but we're on track. We're on track. Yeah. So the STM32 family scales well. Yeah. Stock availability. Avoid hard to find chips because okay, that's something I learned the hard way. Don't work with things that are not easily available because ukichoma moja kupata replacement struggle, and you find like almost everything you've built around it. So like you'll have to like redo a lot of things. So it's recommended to not work with hard to find chips. Work with something that's easily available. Yeah. So basically, those are the factors to consider in choosing your MCU or microcontroller. Yeah, so we get into the Q&A because even we are out of time, kinda. Q&A. So any questions so far? Anyone who has any question, any clarification, anything to add? It doesn't have to be a question. If you have something like you'd like to share, or you feel like has been missed or I did not explain correctly, so yeah. Okay, Collins.
So, Collins, thank you for the presentation. Actually, I've learned a lot today. I don't think I have a question actually. Just I was asking, since you are in the court and you are dealing with this, I was requesting if I could personally come and see your work, at least interact na hizo the MCUs, the Arduinos, niangalie hivi at least nipata ka experience kidogo.
Okay. Okay. Yes, I'm at the court, but currently I'm not around. Currently I'm at my attachment. Currently niko Atacho, so niko Nakuru. But when I come back, okay, in the court, usually I'm at a center called the CDED, Center for Development of Electronic Devices. That's basically mainly where I work on my things. But when I'm around, even Kevin is there, CDED. It's usually at SOE, like hapo juu, like your side. If you know the mechatronics lab where it is, then you climb the stairs, the second floor, on turn right, you'll see like a big door, and it's written there, Center for Development of Electronic Devices. So that's where I usually am. You can, okay, I don't know if you are in the group, right? You can DM me, so like we'll keep in touch. When I'm around, we'll meet. I'll show you around. I can show you seeded the projects that we work on with there. Also things we do at GOAT. Even you said you know Kevo. Kevo is also a member at seeded. Basically that's where I get to like practice my embedded stuff, because we do build a lot of things. We've worked on a air quality monitor, worked on a clocking device, access control, we've worked on speed governors, we've worked on a lot of things. It's a pretty interesting like center, and it's in Dekut. So if you have interests, anyone else, it doesn't have to be calling so only, anyone else who has interests, you can like tunaweza kutana nyuma ya tent.
Okay, thank you.
Yeah, sure. Okay, sadly, currently I'm not around school, but I'm coming back by the end of we're entering April. By the end of April, I'll be around for 5.1. Yeah. Okay. Any other question? Any other add-on? Kelvin Kariuki, I've seen you raised your hand.
Not a question really, but I wanted to inquire. I said that you work on some projects, right?
Yeah, sure.
Okay, so I was asking if maybe you have maybe a WhatsApp group or a page where you showcase your projects. If you can kindly share.
Okay, for my projects, okay, majority of them are, let's say, NDA, because for seeded, those are things that are for seeded, private, for good, yeah. Okay, we have a group for the MLSI IoT where we'll be working on projects together. There'll be show and tell sessions, so you'll be seeing like different projects, things that I've worked on personally and other people have worked on. I'll be showing them. So as long as you are in this group, you can see them. But things I've worked on. Okay, let me share a link to Go Technologies. You can see our products. So these are. Let me share a link to Go Technologies. Or let me just open the page. Let me just show the page so that you can see. Let me share. Give me a minute. I share my window. Okay, one thing about embedded systems is there's never a lack of things to work on. If projects are there's also there's always a project you can work on. Yeah. So we have this startup, Go Technologies. Basically, we build everything IoT. Yeah. So you can see these are products that we have worked on. These are clocking device, a biometric clocking device. So basically, what this is is the GUN1. These are two projects that I've worked on, GUN1 and Got MPPT. These are clocking device. By clocking device, I mean, you can see like in situation like offices or schools, like people come in and out. So like for the staff, instead of like ile kusign kwa kitabu etc, these are devices that people can clocking automatically using the biometrics, the fingerprints. It comes with the attendance management systems. So organizations like schools, hospitals, corporate spaces, they're able to keep track of people who are coming in and out. So these are something that we have I've worked with on, and it's also a project by GOT. Another thing is the GOT MPPT. GOT MPPT. So these are solar charge converter. As normal solar panels, it's the panel and the charge converter and the battery. So the panel, it's the one that it has the piezo, those technologies. Then this charge converter is the one that is like taking in the power and converting it and sending it to the battery. So we created a version of it using the MPPT technology. Though this is something kind of complex, but yeah. So in embedded, basically what we do. So the first part of embedded is the card design, the casing. Okay, though casing comes last. So there's the PCB design. You have to design the PCB, like different components where they're placed. As you can see, this here, this is an ESP, the microprocessor. No, now it's not. You didn't use the whole like ESP. Let me go back to my slides. I think I have slides somewhere. Yeah, where the ESP is. Can you still can you still see my screen? You see, like the normal ESPs are kind of large. This is the microcontroller, but in this case, where is the tab? We worked with only the chip. So the peripherals are things. The capacitors, you can see them here. There's the buttons, the LEDs for indication, and then there's the rating of the firmware. This is something that I worked on. So I'm done who wrote the code for this device, how it's working, sending the data, etc. And then there's the card design, the casing, how it works. This has to be 3D printed. So currently we don't have a physical prototype like the GUN1. GUN1, you can see the PCB. The PCB is for the GUN1, you can see the PCB is ready. This is something that is already printed. You can see it. But for MPPT currently it's not physically available, but we have the design complete, and it's just looking for the funding, etc. So, okay, now that you're here, Go Technology is what we do is hardware manufacturing. We build like the PCB design, card design, etc., IoT development, the IoT device like the GOT MPPT, that's an IoT device. The given one is an IoT device. We do that, and also software development. So basically, that's what we do. Seeded, I don't have the link to Seeded, but yeah. David, I've seen you've raised your hand. Okay. Okay, before you needed David, I hope Kevin have answered your question. Okay, those are the projects I've worked on so far. But with time, if you're part of this series, you'll be getting to see things as they unfold. You'll also work on things. So you also work on things. So yeah, there's a lot to look forward to. David.
Okay, so hello, Collins.
Yeah, hello.
Yeah, so I developed an interest in learning Arduino, but
Yeah.
I don't have the Arduino board. So I was recommended a software Tinkercad where you could just place the component. It has the Arduino Uno and Nano.
Yeah.
So then you the pin. So I was asking, would you advise use continue learning with the software, or it's better I just buy an Arduino?
Okay, I know Tinkercad. It's by the same company that make Autodesk Inventor. Tinkercad
Yeah.
is cool, but
Mm.
the limitation with hacking software, software and hardware, things in the physical world, there are now a number of factors that happen, but that you cannot like experience with the software. I don't know if I have an account here. What I'd say is if you can find a physical Arduino, it would be better. But if you don't have the physical ones, you can work with the Tinkercad. Currently, I don't have an account here, but it's something I've worked with. There's
Okay.
another option to Tinkercad, the Walkway, which we covered last week. Walkway
Okay.
is you can also use to simulate like the ESPs, the Arduinos, the Rasp.
Okay.
Walkway. Let me share the link.
Okay.
Walkway.
And
Walkway is kind of better than Tinkercad. And okay, the thing is, Arduino is limiting. So if you're into embedded,
yeah.
you'll outgrow Arduino very fast. Like Arduino is, I'd say, like stage one of like embedded systems. You can see this is Walkway. So you see there are a number of microcontrollers, the Arduino, the Uno Mega, the ESPs, the STMs that you have I'd mentioned, the Rasp, which I don't know why I didn't cover Rasp in my session today, but Rasp, they're very, very good MCUs. Because you're using Arduino, yeah, you can see there's the Uno, Mega, Nano, at Tiny. Which one is this? Francisino. I've never had that one. They also have the ESPs. You see the family that you have covered, the ESP-2, S2, S3, S6, C3, C6. You see that Woku have a larger variety of microcontrollers compared to Tinkercad.
Yeah.
The STMs, you see, yeah, the STMs. They have the Nucleo. Okay, they only have Nucleo. Nucleo LO31K6. What I'd say is, nobody is forcing you to have. It's recommended to have a physical microcontroller and like components, but if you don't have them, because the biggest challenge with embedded is hard access to hardware, because these are things that you have to buy, and some of them are not cheap. Like the rasps, rasps are very expensive. Some rasps go up to like 15,000, so you can imagine. So if you don't have access to hardware, it's okay. It's okay to work with simulation. Nobody is against that, but it's recommended to have physical hard MCUs.
Okay.
If you want to like get microcontrollers, there's this company Pixel. Pixel Electric. Yeah. They do sell microcontrollers, and at a very affordable price.
Okay.
This is why you can find development boards. So if you're looking to buy like a physical board, this is where you can find them. You can see like this Arduino Nano is 6800. You see, some of them are not cheap. Like the Rasp Pico is 1300. Yeah, so if you're looking to buy physical like hardware, which is recommended, you can find them here. But if you don't have the money or the ability to get them, it's okay to work with the simulation. Nobody is against that. I
Okay.
hope I've answered your question.
Yeah.
There is the link to Pixel.
Okay.
Any other question? Okay. So if you don't have questions, then I can ask a question. So we are entering a new month. So what are you looking forward to in this new month? Anyone who can just share, like, we're entering, this is the last day of March. Tomorrow will be in April. So what are you looking for, or your goals this April? So it's a pretty simple question. Anyone who is open to sharing. Okay, let me start. Okay, being a new month, okay, personally for me, there's a project that I want to complete, and I'd like to get like at least one guest on this IoT 101 series. So if by the end of April I can get at least one guest speaker to come and talk to us, and I finish a certain project that I'm working on, it will be a good month for me, and good health for me, my you guys here, my friends, family. I'll call it a good month on my end. Anyone wants to shout they're looking forward to the month of April? Oh, by the way, if okay, I don't know if there are any Muslim brothers here, but Eid Mubarak to you all. I didn't wish you at the beginning, but yeah. Collins.
For me, all the Muslims here, thank you for fasting. And today mnaweza kula hasa kwa amani.
Yeah.
So what I'm looking forward into this month ni probably to network with people. Nataka tu wale watu tufanye tu projects pamoja, tufunzane tu hapo hivi. I've been really looking for a network. You know, hivi tu ukiwa na team, you'll not struggle so much because kuna venye tu teamwork yani is always better than being alone. So kama kuna mtu hapa hivi anataka tuunde team hapa hivi, at least tujulianange hali hivi, tujue pale unasonga, I'll be glad. And probably na wish to kila mtu a good health throughout this coming new month. Thank you.
Amazing. One thing about this series, I'm trying like to build like an IoT community. So if you're looking for people to work with, that's something that even me, I'm looking like to build a community where people work on things together, build projects. When I was talking about the series, you mentioned that I said like IoT 101 is a community series. It's a community, not me coming to teach you things. It's us working together to build things together. So as long as you're in the group and we are all here, whether you guys should DM me. Like I'm always available to assist you. Like even just if it's just talking my story, nipo kujuana. So yeah, and those are good things to look forward to, and it's nice that you have shared. And we wish that the things that you're looking forward to can unfold. Kelvin, you raised your hand as we conclude, because we have 15 minutes
Okay,
past time.
hello.
Yes.
Okay, hello guys. Okay, I agree with the Corins, and also I agree with you that IoT should be a community. We should at least build a community where we showcase our ideas and work together on projects. Okay, I have just had a simple thought when you asked that. Okay, in this world, we can say that we are not just there to just live and die. We should at least build some things which will leave an impact in this world. Being a third world country doesn't mean that we can't build something important, but we need to collaborate. Okay, as much as you can do things around, it's good to collaborate and share it with other people. Yeah.
Yeah, that's pretty profound. Yeah, being a third world country. Okay, one thing about Kenya or Africa as a general, uh, it's like people don't believe that we can build things. If you look at Kenya, then the number one imports are machinery and electronics, and these are things that can be built here. And if and looking at the demographic of the world right now, majority of the young people, the resources and everything is here. So if we can, us as ourselves, like empower each other and grow together to build things, work on projects, I believe that we can come from third world countries to first world countries. It's just having that drive that currently we're in the fourth industrial revolution, and Africa was left behind in the previous one. So as even us as the youth, we should just like rally together in things like this, learn, build together, and you never know. Because okay, go and look at the top 10 richest people in the world. Majority of them are from tech. They build something, so you never know what you'll build. It will change a lot of lives, save a lot of lives, yeah, and empower a lot of people. So as long as you are here with the urge to learn, and I'm here to ensure like knowledge is available to everyone, and people get to network and grow together. So I'm looking forward to seeing how things unfold. Vance, thank you for that, Kevin, and that was pretty profound.
Yeah, so hi everyone.
Hello.
Yeah, actually, I'm so happy to have these sessions. I'm not a student at Dedan Kimathi from University of Embu, and I happen to at least kuingia kwa group ya CDG ya Dedan Kimathi. So at least I'm happy for this chance. Yeah, and actually hiyo strategy yenye unasema we need to have at least like nika channel yenye we can have a community yenye we can saidiana, because actually I've been trying to work on something with tiny machine learning, nikijaribu hata kuingia like YouTube, it's still challenging because unapata there is still no resources, unachapa tu blogs, tutorials, like kinda it's hectic. So even if you have maybe a big idea in a like limiting, either due to resources or that knowledge, yeah, or so. But at least if I know maybe I can have this maybe startup idea, nipe kolwa changamki stuff, maybe the other one the 3D printing nini, and it will be at least kitu tutachapa tu fiti and very fast, yeah, na tuinuane. Thanks.
Yeah. Sure. And that's one thing that we are trying to like to do with the IoT 101. Basically, right now we have the WhatsApp group. I hope everyone here is in the WhatsApp group. I've shared the link I've shared the link in the chat. So basically, that's so if you have a problem or anything, any concerns, we can be sharing there. If you have a project idea, something you need people to collaborate, you can just share in the group. We'll be rallying people, like trying to work together, share ideas. So basically, that's okay. Right now, it's still the beginning. So, but with time, you'll see that the community we'll just be growing together step by step, project by project, session by session, knowledge by knowledge. This is a community series, and I'm looking forward to like being that it's not only me that I have to like lead the session. Like next week, like Vance, you can showcase your TinyML project, or which TinyML. I know a number of people who are working on TinyML. I also a good friend of mine is like the lead of TinyML in the code. So your issue, like you can DM me and we can try to look into it together. Yeah, but the issue of community people that can work with, that's something that, especially for embedded systems IoT, you not only need community, you need people you can exchange and share components, because I cannot buy every other component that I need. You need people like I can come borrow an ESP from you, borrow an RFID reader from another person. You see, those are the limitations. For the software guys, you only need to like download libraries, but for embedded guys, that there's that limitation of hardware, which that's getting into your pocket, and I don't have to get into my pocket if I know a person, or I have a community where someone might be having something that I need. So yeah, basically that's the goal, and there's a lot to look forward to. So kwa group, msinyamaze sana, tuongee, tujuliane hali, and na kama uko hapa pia ni DM pia. Mi napenda sijui kama uliona ile message nilituma, nilisema I'm hoping to make a friend here, so hopefully mni DM me. I want new friends, connections, because huku nje ni ma connections. Yeah, yeah. Okay, I believe there's no one else having anything to add. Okay, if there's no one else, oh, I should have stopped the recording.